Okay, picking up from the last video, to get the slope of our red line, which is our secant line passing through negative 3 comma 9 and negative 2 comma 4, we just did this, the difference of the y coordinates over the difference in the x coordinates, which is going to be f of neg 2 minus f of neg 3 over neg 2 minus negative 3. So you get 4 minus 9 over negative 2, and that turns into plus 3 when it's over with. So now 4 minus 9 is negative 5. Negative 2 plus 3 is positive 1. So 4 minus 9 is negative 5. Negative 2 plus 3 is positive 1. Positive 1. I keep wanting to say it wrong. So we get negative 5 here, 4 minus 9, and positive 1 for negative 2 plus 3. So negative 5 over positive 1 is negative 5. So that's the slope of our red line. And now remember how to get the equation of the red line. So to get the red line equation, you do y minus, now pick either one of the two. You could pick either coordinate. You could pick either the neg 3, 9 or the neg 2, 4. I'll pick the negative 3, 9 since it's what we're going to zone in on today. You could pick the other one just as well. So y minus 9 equals, now this is point slope, remember? Now we determined that the slope was negative 5 for the red line. So that's negative 5 times x minus a negative 3, but that's x plus 3. Okay, which amounts to, which is the same as saying y minus, well, we can distribute the negative 5 on through, and we get negative 5x minus 15, which means, oops, that's not a 0 there, that is a 9. Sorry, I just mistyped it. That's a 9 right there. So I distributed the neg 5 through the x plus 3, and then which means, now if I add 9 to both sides, I'll get y equals negative 5x minus 6. Because I add 9 to negative 15, I'm still, at minus 6. I'm just not as negative as I was. So I add 9 to both sides. And that's where this guy right here comes from, this negative 5x minus 6. That's how we get the slope of the secant line passing through these 2 points. Now observe, guys, that h is, well, what is it? What is my h here? Relative, no. Observe that, and for my red line, and I should have put this right after I defined my red line, but observe that h equals, well, what is h? It's the difference in my x coordinates. I want since negative 3, 9 is the point I want to focus on, I want it to be on the butt end of my minus sign. So I want to put negative, it's the difference in my x coordinates. It's negative 2 minus negative 3, which is equal to positive 1, because that's negative 2 plus 3, which equals 1. So observe that h equals positive 1, and even before that, my c, since I'm focusing, I want my c to equal negative 3, which means f of c is c squared, which is 9, okay? And I hate it, well, I'm going to have to create a space just to prevent that, sorry. So I'm going to focus on negative 3, 9, so my c coordinate, which is my x coordinate, or my c value, which is my x coordinate, I want c to equal negative 3. And remember, f of x is x squared, so I square negative 3 to get 9. So, and to get h, the point we're focusing on, actually, I want to be on the tail end of the minus sign. So negative 2, 4 is my other point. That's the point I'm not focusing on. So negative 2 goes in front. Negative 2 minus negative 3 is 1. So my h value, h equals 1. So h equals 1. So really, you know what? So my h value is 1. And really from that, I already knew my denominator would be 1. So really, from that, I already know that, like when I get my slope on my red line, that when I do delta y, or my change in y over my change in x, I already know that my change in x will be positive 1. Now my change in y, I have to dig just a little bit more, but I don't have to dig too hard. To get my change in y, you have to actually go in and do f of neg 2, and you have to go in and then do f of neg 3, and then subtract f of neg 3 from f of neg 2, and you get negative 5. But negative 5 over positive 1. Now h doesn't always have to be positive 1. It just happens to be in this particular example. H could equal other things in other examples, okay? But anyway, now let's put all this together. So the red line is my line passing through negative 3, 9 and negative 2, 4. Now my red line is not going to be my, it's a great secant line. It's a pretty good looking secant line, but it's not my tangent line. The gray line is my tangent line. Now, my tangent line, I went ahead and gave it to you. It's gonna be this guy right here, but now I need to show you how to get the tangent line. So to get the tangent line, I need to take the limit as x goes to negative 3 of the difference quotient. So now here, this was just an artificial still fixed difference quotient. Nothing was moving. I need to put the limit on and make things move. What we're going to do is we're going to take negative 2, 4, and we're going to move it arbitrarily close to our point of interest, which is negative 3, 9. So, and really I shouldn't say tangent line. What I mean, I'm interested in the tangent line at negative 3, 9. So the tangent line that I want is the tangent line at and just because I just want to pick on negative 3, 9. It's not that negative 3, 9 is any better than negative 2, 4. I just want to consider negative 3, 9. So I want the equation of the tangent line of y equals x squared passing through negative 3, 9. I would type all that out, but I don't feel like it. We typed it on Word, a while back in the general form, not using this example. But I want the equation of, well, let's see if I can type it out. I want the equation of the tangent line passing through the tangent line of y equals x squared, I should say, passing through, and I'm in the mood to pick on, you can pick a lot of points, but I'm going to pick negative 3, 9. Okay. So I want that equation. Now, how do I get it? What I got to do is, it would be handy if I could open up a different Word file. I need to get the slope of that line. It's going to be negative 6. And I claim for any c value, it'd be 2c, but let's not go there just yet. But I claim the slope of this gray tangent line. My tangent line is the gray line. I claim that slope is going to be negative 6 for the gray line, which is my tangent line. But we need to do the limit of the difference quotient, which is the derivative at that point. Okay. So I want the gray, notice, guys, before I do that, the gray line, let's just look qualitatively. The gray line is the line of best approximation. Notice it's a little bit better at hovering close to the graph relative to negative 3, 9 than the red line is. The red line's not bad, but the gray line is even better. Relative to negative 3, 9, the gray line is even better at hovering very close to the graph at negative 3, 9, and that's no accident because it's my tangent line at of y equals x squared at negative 3, 9. That's what the gray line is, so it better act that way. So let me pull up a Word, and just remember again, you get your slope of your red line, then and to get the red line, you do point slope like this. You need both points to get the slope, but then you'll just pick your favorite point and then go to slope intercept. It's standard practice to go to slope intercept. People just like to do it, but there it is. That's the red line. Now the gray line is more. It's a little delicate. Now the gray line, we have our point. We know that once we get the slope, we're in good shape because we're passing through negative 3 comma 9. But getting that slope, that's going to be sort of the fun part because we've got to take the limit of the difference quotient, which is the derivative. And let me get honest and do it. So let me just pull up a new word, if it will let me. Okay, so I need to take the limit, and I hate that. Ooh, that's awful small. So take the limit. I need to take the limit as x goes toward negative 3 of the difference quotient f of, well, you know what? I could either way. Since I've been talking to you about the difference quotient, why don't I do the alternative version? Take the limit as h goes to 0 of f of, well, negative 3 plus h. Now, in my fixed example, h was 1, when I had f of neg 2, but now we're not doing that anymore. We're done with the red line. We're doing the gray line, and we're moving our bead from negative 2, 4 away, and we're moving it arbitrarily close to negative 3 comma 9. So here's, I'm wanting f prime of negative 3. So over h, and guys, what are we finding? We're finding the slope of that gray tangent line, okay? So the slope of that gray tangent line, that's f prime of negative 3. Let's just go ahead and give it a name. That doesn't, that's going to give us the appropriate name, keep things in perspective. Okay, but now remember, f of a number or a letter is just the square of that number or letter respectively. So I just take whatever's inside and I square it. So it's negative 3 plus h, which is h minus 3, by the way. But anyway, so squared minus, and then I square, f of x is x squared, so I just take whatever and I square it. That's what f does to the term, it just squares it. It takes the square thereof, and then over h, and then that equals, now I've got to do some FOIL, or actually perfect square formula, or you could multiply negative 3 plus h by itself and do FOIL. Let's just do the perfect square formula. You're going to get 9, let's see, by perfect square, x, let's see, a plus b parentheses squared is a squared plus 2ab, but since that's a negative 3, that's going to be a minus 6, and then an h, and then plus h squared. I use the perfect square formula, or you could FOIL, you could do a parentheses negative 3 plus h times another set of parentheses negative 3 plus h and do FOIL. Okay? And then minus, now this minus sign survives, but this minus sign is going to get squared away as positive 9. Be careful there, okay? And then all that over h, and then that equals, now this 9 and negative 9 are going to cancel. Oops, I forgot my limits. Sorry, guys. Forgot my limits. My bad. Oops. Everything I said was good. My DQ was perfect. I just forgot my limits. How do you like that? So let me cut that. Sorry, I'll hurry this up. Then Control V. And then I need to do the same thing here. Oh, I'm getting sloppy. So let me get that, let me cut and paste. So everything I said was good. I just forgot my limit symbols. Not cool. So let me cut that and insert my limit. So h goes to 0 and repaste that. Okay, and again, just like we said before, these 9s are going to cancel, and so I get the limit as h goes to 0, and I'm just going to cut the 9s out. And then we just get, on the numerator, I get negative 6h, and then the plus h squared, and then, just h down there, obviously. But lo and behold, look what happens. Well, let me do my limit before I get excited. So limit, as h goes to 0, and let me not get ahead of myself here. So I get h, and then I get negative 6 plus h. Hey, lo and behold, you see this h up here and this h down here? What I did by algebra, I factored out an h. These terms both had an h in them, and that's going to chop the exponents down by 1. Well, that negative 6h is going to lose, it's not going to have an h anymore. And then h squared just becomes h, because I divided when you factor out an h, you divide each term by that letter. So you divide each term by h. Negative 6h, if I divide h, I just get negative 6. And h squared divided by h is just plain h. So I factored out h. But then these two will cancel. Okay. That's what it's all about. That was the that's the thing I've been wanting. Cancellation is what it's all about. That's what we really want. That was really our motive. So equals, limit, and well, I must have did something crazy. Let me get rid of this. Equals, and then type in my limit. Okay, so that's equal to the limit as h goes to 0 of just negative 6 plus h. And I need parentheses just to be good, because just to indicate that this is all inside my limit. But really, we know from what we said about limits, yeah, that's just negative 6 from the things we said about limits. Oh, okay. There's my slope. That's good. The hard part is done. Well, oops. So there's my slope, and it re-indented it, or refunted it for me. But anyway, so f prime of negative 3 is negative 6. So my tangent line equation is, which is what I'm after. That's the big guy I'm after. So now in point slope, you remember we're passing through negative 3 comma 9. So we do y minus the 9 equals my slope, which is my derivative. Derivative is slope, by the way, negative 6. And then I do x minus a negative, which is x plus 3. And I'm really done if you want point slope. But, we're perfectionists and we like to get slope intercept. So, which means, I wish it wouldn't capitalize it, but I may just have to live with it. Well, now let's see. Let's see what I can do. Which means, and let me insert, so y minus 9 equals, distribute neg 6 through, negative 6x and minus 18. And then, which means, add 9 to both sides, and we get it's going to be minus 9, or yep, minus 9. So, and notice that this right here is called point slope, and this down here is called slope intercept. A lot of times, a lot of books will like you to get slope intercept. It just depends on the book and the situation at hand. But I like to go all the way and get slope intercept. And observe, guys, you see that y equals negative 6x minus 9? That is this guy right here, where my cursor is. And that is the equation of my gray line, where negative 6 is the slope, which is the derivative of y equals x squared at that point. Just at that point, mind you. So negative 6 is the derivative of y equals x squared at the Cartesian coordinate negative 3 comma 9. And negative 9 is my y-intercept. So notice this gray line, it hits the y-axis down here at 0 comma negative 9. That's my y-intercept, or my b, as they call it in algebra. So negative 6 is my derivative slope. Negative 9 is my y-intercept of the gray line. So this gray line right here. And we've been doing the gray line for a while now. Anyway, that's the visual meaning of the derivative. It is laborsome to do this a lot, but I think it's important that you understand the visual meaning of the derivative. It's the slope of the tangent line at the point you're taking the derivative of. Like, if you're doing the derivative at like negative 3 comma 9 for y equals x squared, the slope of the tangent line at negative 3, 9 is that derivative. Or the slope I should say the slope of the tangent line passing through negative 3 comma 9 is that derivative. But anyway, thank you, and I'll see you on the next video, and we'll do some examples.